Okay boys, so today we're just going to do a bit more on conversions just because there's a whole lot of new terms and things in this, so we'll take it a bit slower. Alright, so a couple of the prefixes that I didn't mention the other day, they don't get used a lot, but I'll just throw them in anyway. But deci and deca. So deci is something that's smaller, so if it's a decimeter, it'd be smaller than a meter. And it comes from the word decimal. Right, so a decimal is a small thing, like if you think of a decimal as something lower than 1. I know decimals can be anything, but let's just think of it as something small, a part of something. Okay, so deci means we're doing 1/10 of it. Deca, they both start with DEC, notice, they're both 10. Deca is the bigger thing, it's 10 times. So if you think of a decade, that's 10 years, so it's 10 times 1 year. Alright, now with length, we're just going over a few extra bits and pieces on top of what we did last lesson. So this one you should already know. On your ruler, 1 centimetre equals 10 millimetres. So if you're converting from centimetres to millimetres or millimetres to centimetres, you will be using a 10 to do your converting. 1 AU. An AU is an astronomical unit. It gets used in science more than it does in maths, but you will need a lot of maths in your science to do it. It's to do with distances in space, and this is what it equals. 1 astronomical unit equals 149,597,000,000. Sorry, what have I said there? It's 149,597,871 kilometres. Okay, so 1 astronomical unit. It's a big distance in space. Okay, and 1 LY. LY is a light year. So a light year is the distance that light will travel in 1 year. And this is how far light will travel in 1 year. 9.46 times 10 to the power of 12 kilometres. Alright, so in a year, that's how far it goes. Again, this really is involved in talking about distances in space. Alright, so we have mass. To do with mass, you already know this probably, but I've written it down anyway because it didn't you need to know it. So a T is a ton. It's not a ton. Ton comes from the imperial system that's used in the United Kingdom. All right, but, used in the United States. All right, but we talk about tons. It's T-O-N-N-E, not T-O-N. All right, so 1 ton equals 1,000 kilograms. So if you think of a car is around about a ton. It's probably a bit bigger on some cars and about a ton on most cars. Alright, time, we've covered all the conversions for time when we did the earning money topic, so I'm not going to go through that again. You should know all of that already. Okay, so I'm just going to do some examples involving these other things just to make sure we've covered everything. Alright, so looking at the first example, we're converting here. So we have 9.4 tonnes to kilograms. We are going to a smaller unit, so we're multiplying. Now remember there's 1,000 kilograms in a tonne, so we're going to times by 1,000. And if you do that on your calculator, you'll get 9,400 kilograms. Next question, 29.375 tonnes. We're converting to grams. So you can't go straight there. Right, this one's a bit different because it looks like with what we're doing we might be able to, but you actually have to go through kilograms first before you get there. So we are going to a smaller unit, converting from tonnes to kilograms. So we're timesing. Remember there's 1,000 kilograms in a tonne, so we're timesing by 1,000. Now going from a kilogram to a gram, we're still going smaller, so we're multiplying by. Now there's 1,000 grams in a kilogram, so times by 1,000. So if you do all of that on your calculator, 29.375 times 1,000 times 1,000, you'll get this answer, grams. Just make sure that you're not doing something like timesing by 2,000. Do everything, otherwise you're going to get a wrong answer. All right, this one, minutes to hours. We're going to a bigger unit, so we're dividing, and there's 60 minutes in an hour. So we're doing 240 divided by 60, and that will give us 4 hours. So the time I'm not going through now, all the conversions of what means what, because we did all of that earlier in earning money. Down here we're going from seconds to hours. You can't go straight there, you'll need to go to minutes first. So we're going to a bigger unit. Seconds to minutes, we're going to divide by 60 because there's 60 seconds in a minute. Minutes to hours, we're going bigger again. So we're dividing. And there's 60 minutes in an hour. So we do 144,000 divided by 60 divided by 60. And we get 40. So the answer is 40 hours. Notice we are not dividing by 120. We're dividing by 60, dividing by 60. Okay, so in the next question. Now, this is where you have to think because we're doing word problems here. This is all to do with rates. Rita made a video call lasting 1 1/4 hours. If it used 3 megabytes per minute, how much data did the call take? So, to get the amount of data, we're going to do 3 megabytes per minute. I like writing it like that. Now, if we times by the number of minutes, these things effectively cross out and will leave you with your answer in megabytes. But you need to have that time in minutes, and at the moment, it's 1 1/4 hours. So we have to come over here. You're going to a smaller unit. So you times by, there's 60 minutes in an hour. So if you do 1 1/4 times 60, you'll get 75. If you do that on your calculator. All right, so then we can put that 75 in here, and then we just need to do 3 times 75, and you'll get 225 megabytes. Okay, looking at the next question. Calculate the number of MP3 files of average size 5 megabytes that can be stored on a 64 gigabyte MP3 player. Try to block out the MP3 because it's just giving us more letters than we really need to be looking at. So we've basically got 64 gigabytes and we want to know how many 5 megabytes go into that. So we're doing a division, but we've got to have that in gigabytes so we can just cancel those out and get our answer. And at the moment we've got 5 megabytes. So we need to convert from megabytes to gigabytes. You go through the base unit first, megabytes to bytes. We're going smaller, so we're timesing, and mega means a million. So we're timesing by a million. Now if we go from bytes to gigabytes, we're going to a bigger unit, so we're dividing, and giga is a billion, so we've got 1 and 9 zeros there. So if we do that conversion, so you just type in 5 times a million divided by a billion, you will end up with, just squeezing that in, hope you can see it, it's 0.005 gigabytes. That number goes in here now. And so now we're going to do this division on our calculator. 64 divided by 0.005. And we get an answer of 12,800. And it's the number of files, so we're going to write files after that. Okay, so in the next question, number 4, I'll just move this over. All right, so boys, we're going to be converting and we are rounding correct to 2 significant figures. So, looking at the first question, we have 3.5 astronomical units. We're converting to kilometres. So back over in the notes when we wrote them down, we said 1 astronomical unit was 149,597,871 kilometres. So we're going to a smaller unit, so we're going to times by that. no one's expecting you to remember that number off by heart. If you're going to be using this in an exam, we will give it to you. Okay, so now we're just going to type that in our calculator and see what we end up with. So we've got 3.5 times 149, 597, 871, and this is the answer we get. Now, that's the answer off your calculator, but they've asked you for two significant figures. So we have to round it. So here's your first significant figure, here's your second. We're rounding here. Our decimal point's all the way over there. So we still do our rounding here. That's less than 5, so this stays. So that's going to stay at 2 and that will stay in front of it. Now, you have to make sure you occupy all those decimal places up to the all those spaces up to the decimal point. Okay, so 1, 2, 3, 4, 5, 6. We've got 7 spaces we need to occupy. So we fill those in with zeros. And that's your answer. Round it off. Now we've just got to write the kilometres on the end. Okay, let's try the next one. So this is 0.94 mega, can't remember what it means exactly, the A, but it's to do with annum, all right? So I'm going to call it a mega annum, because A for annum means years. Okay, so that's what the A is talking about. So it's basically mega years. It's a mega is a million, so it's like a million years. So we're going to convert it to years first. So we're going to a smaller unit. So we're multiplying by 1 million. And then we're going to go from years to millennia. Now millennia, mil means 1,000. Remember? So it's 1,000 years we're going to. All right? So we're going from years to 1,000-year blocks. Okay, so we're going to a bigger unit because a millennia is 1,000 years. So we're going to divide by 1,000. So we get our calculator and we type in 0.94 times 1 million divided by 1,000. And the calculator gives you 940. Now, we've got to check on the significant figures. We've got 2 significant figures we're rounding. That's less than 5, this stays. That'll stay in front. And we have to occupy the number up to the end of the number, which is there, with a 0, which it already has there. So that was already written as 2 significant figures. Now we're going to write millennia on the end. And that's your answer. Now, the only thing I haven't really covered here is just in case you get some of these types of questions where the calculator gives you a scientific notation answer. So, for instance, if your calculator, you don't have to write this down unless you want to, but if your calculator gives you something like this, if it gives you something like that, then all you're doing for your rounding is looking at this first thing here. You're only looking at that, right? The times 10 to the minus 6 will stay. So if they want it written as 2 significant figures, you're just going to go, well, let's say 3 significant figures because it's how I wanted this thing to work out. So 1, 2, 3. That tells you to take that up by 1. So that'll become a 9. Everything in front stays. And that's your answer. That is written to now to 3 significant figures. Okay, so that's just in case any of the answers turn up like that. So you keep the times 10 to the power, whatever it happens to be, stays. And it's just this thing here at the beginning, the decimal, that you're rounding to the significant figures. Okay, good luck with your homework. See how you go.